We just got through finished talking about the nodes. Now we'll move on to the links. I think we'll just do conduits in its own video, just because like inlets and junctions, it's a little bit more detailed, and then the rest of these will go in the last video for links. So conduits. First of all, we'll open the attribute table, right click, open attribute table, and then dock the table. And conduits don't have a flow2d file like your inlets have swimflow.dat and your outfalls have swimoutf.dat, but conduits don't have a flow2d file, so they're completely contained within the INP file. So you need, let's see, individual name. Each conduit needs an individual and unique name. You don't need to fill out or even have these node name fields for this data. They are in this data. Storm drain conduits. They're in this data. Okay. So you don't really need these. Our assign tool will assign those. You do need offsets if you have them. Offsets are very important. And the shape needs to be, if you have a shape, the text is a specific style, so it will need to be all caps and the correct spelling. Number of barrels, you'll need either one or greater number of barrels. The maximum depth is the first geometry of the conduit, and then geometry 2 would be, so this, if this is maximum depth, this would be width, and these two would be other, like closed, like if you had a closed trapezoidal conduit, that would be side slope 1, side slope 2. This would be the length of the conduit, the roughness of the conduit, and whether or not there's initial flow, whether or not there's a max flow, and then the entrance, exit, and average loss coefficients, and whether or not there's a flap gate. Okay, so let's get into some of the details of these features. Let's start here, where we look at, this should be over here. This is not a header. So this is the first attribute is name and string. These ones aren't needed. Inlet and outlet offset, those have to be separate fields, and they are both real. Precision 3, or your choice on the precision. The shape is a string, number of barrels is an integer, the maximum depth is a real number. This is maximum or geometry 2, 3 and 4 all real numbers. Length real number, Manning's N real number. Initial flow, max flow, entry, exit, and loss coefficients, those are all like factors, and k factors, and then the flap gate is an integer. So in flap gate, integer is usually on and off. So let's take a quick look at these variables in the swim GUI. And let's get to a better place here, like a place that actually has a more realistic looking conduits, because we're going to look at the conduits and we're going to look at the profiles. So conduit attributes. If you double click on a conduit, you see that it has the conduit name, the upstream node, and the downstream node, and the geometry. So let's focus on this geometry for a minute. So here you have a geometry selector. So if you want to know how to spell the different geometry types, you're going to get that from this storm drain editor. And then if you clicked on a closed rectangle, you'd see that this is maximum depth and this is geometry 2. I'm going to cancel that because I don't want to accept that. Length, roughness, offsets, initial flow, max flow, loss coefficients, and whether or not there's a flap gate is just yes or no. And I don't have a culvert code for any of these. Okay, so that is the attributes required for conduits. Now let's talk a little bit about the profile. So usually if you have an inlet offset or an outlet offset, like that would mean that if those two numbers were vastly different, that could invert the flow direction of your conduit. So let's take a look at this really quick. This is kind of a weird system right here. So what I want to do is I want to do something strange, okay? I want to select this node, and I am going to use this tool right here, and I'll set this node as the start node, and then I'll set this node as the end node, because maybe it looks like this flow goes downhill. It doesn't, I mean, it doesn't, but you'll see what I mean in a second. So if you look at this, this is the start node and this is the end node. And you can see that, that I have drawn this profile in a manner that doesn't make any sense. Because what happens in this system is that this conduit, let's see if I can pan a little bit here. The water from this system flows in this direction, and then it gets down to this drop box this flow exchange box manhole right here, and it actually feeds two different systems. So this pipe comes down here and feeds this system, and then this pipe feeds both systems. So if you if you map this correctly and you see from here to here, and you can see that that is an accurate and valid looking profile. And if you did it from here, let's do this again, but we're gonna so our inlet node is up here, but let's make our outlet node this guy right here. Now you can see that this is going from our inlet to our outlet in this direction, see, and so it's going, the water is flowing this way. And then we'll do that one more time where we'll get this as our inlet node, and I think we should still be on this guy as our end node, and click OK, and you can see that this is the flow, and then of course this is our intersection where the conduit size changes. So if one of these one of these conduits was reversed, the direction of the shapefile was reversed, that might mess up this profile. So let me show you what I mean by that. If we come into our conduits and we double click our conduits, we can change the symbol, we can change the symbol to arrow, and I'll click apply, and then I'll click OK. And once you're in here, you can see that indeed you can see the flow direction indicated by these arrows. Sorry, I don't know why those look so funny. There we go. And if you were building this system and you messed up your arrows, one of the things that you could do is you could come in here and you could start editing, and you could use this advanced toolbar. So if you right click toolbars and choose advanced digitizing toolbar, this toolbar has a line reverse tool, and the line reverse tool is very awesome, because not only does it work on individual lines, see, it changed the direction of that line. It's kind of hard to see because we can't see our arrows very well. Let's see if I can get one that has good arrows, but you can see that it will change the direction of your line, and even if it has more than one vertex, it doesn't matter. It will reset the vertices in the right order to change the direction of your line. So it's really cool and powerful tool if you accidentally put your conduit in backwards when you're digitizing these layers. So you do a lot of digitizing. You build these layers yourself when you're building a storm drain system. Okay, so I just wanted to show you that flow direction. And let me get this. Now I want to change the color of this line. I want to change, let's choose a graduated color. So here's our symbol. Let's graduate the color by maximum depth, and let's choose like a pretty bright colors, and then we click classify. And so these would be the colors. Actually, that doesn't make any sense because this color is too close to this color. Let's make one that's more like this one. Blues is fine. Okay. And so low values are closer to white and the darker values are closer to bright blue. And we click apply, and then you can see that we can change the information that's plotted in this system by changing the style of the conduits. And you have complete control over this, and you can decide how many units of data that you want, and so it just makes it easier for you to see your conduit flow direction and the diameter of your conduits. All right, so let's see what is next. Okay, that takes care of Directions, number of barrels is probably pretty self-explanatory. Oh, conduit length. One of the things with Flow 2D that you need to be careful of with respect to conduit length is we have a 30-foot grid system, so we try not to have like a pipe length that's less than the grid element width. So if your grid element width, and typically in urban modeling we do like a 20-foot grid size. I've seen 15, I've seen 10. I don't like going down to 15 and 10 because it makes channel modeling really hard. So I like to stay around 20-foot grid cell size for urban projects. And so if you are doing conduits, you want to modify these nodes so that, let's put this to length, and let's just select the lengths that are less than 20 and then reset those to 20 and click update selected, and then we will turn that, and then we will and then you can see that we no longer have conduits that are less than 20. Of course, this cell size on this project is 30, but you get the point. You want it to be, the minimum length should be about the width of a grid element, so that the time step makes sense when the storm drain model flows. Okay. What else do we have here? Initial flow, max flow, and let's just show you information about these loss coefficients. So if you go to the EPA SWIM GUI and you open the help manual, which is help topics, and then you'll hit the search and just type losses. Let's try losses. You can get conduit properties, and you can get some loss coefficients for entrance loss coefficients and exit loss coefficients, and some average loss coefficients, some ideas and methodology for that if you click on some of these topics. Okay, so that's loss coefficients. And then we have, let's get back here, and then of course a flap gate is pretty self-explanatory. If a flap gate is assigned, I think it's usually assigned to the end of the conduit, or yeah, you would assign it, I believe it goes to the end of the conduit. It basically just prevents water from backflowing into the conduit from the downstream side. Okay, so I'm going to turn this off and discard the changes. I don't want to lose my changes for my next video. And that's it for conduits. So I'll stop this video, and the next video will cover pumps, orifice, and weirs.